annual conference.
Working? Yeah.
All right, I'd like to introduce Ralph Baer to everybody here. Thank you all for staying, and I think most of you know from what I wrote and what Adam wrote, we met Ralph earlier in the springtime, right after the last April show, actually, I believe. And we went to his house, we sat and talked for a while, had some great conversations. He told me about things I hadn't really thought about because he's got a couple of years on me. And I hope when I'm anywhere near Ralph's age, I'm doing half as well. An interesting man, a wonderful guy to speak with. He's done many, many things beyond the scope of what I've done. And I appreciate you coming down to talk with us, Ralph. Thank you very much.
Okay. Is this working? Can you hear me?
Oh, yeah.
The only thing I will need is a higher chair and I'll be over because I need to sit. So if you guys can't see me back there right now, I apologize, but my back is 92 years old and it doesn't like standing up. Well, I got invited here mostly because before World War II, I studied radio from the National Radio Institute correspondence course in '39. By 40, I graduated. I got the factory I worked in. I started servicing radios on Lexington Avenue between 78th and 79th Street. No, that was 78th and 79th. In a store that I called racing in D.C., we had another store on 3rd Avenue on 72nd Street, eventually a third store on the west side. I did all the service work. There was no car, and it was a real joy servicing some of the stuff. Carrying a chassis with one hand, the speaker in the other hand, you know, getting in and out of a bus. Two bucks on the arm. No car. Talking about cars. Well, we just gained 4 inches.
There we go.
All right, so when it comes to old radios, I go way back. The real joy in those days was servicing car radios. I don't know how many of you guys collected them because they're horror shows, all of them. Right? There's a power supply on one side, with either a vibrator and a rectifier, or just a vibrator that makes more noise. And if any of that equipment existed today, it would be banned by the FAA because it made more noise than it created these in those days we had 6 modes in the car. The car radio consisted of the power supply, the radio itself, all under the dashboard up against the firewall. Flexible cables coming up to change the tuning and volume. Antenna under the running board, remember running boards now? Antenna, a wire under the running board. There were no whips yet, before whips. And to service them, of course, you had to turn around, put your feet on top of that one seat, and work like this. And guaranteed to get a hernia after about 6 months. It was really bad. Anyhow, I serviced radios there for three years, and then the Army got me and I went overseas as a military intelligence guy. Came back, having made myself a weapons expert, gave that 18 tons of a lot of small arms. I've written a book on some machine guns, history of machine guns, totally different life. And then went back to school, became a television engineer by degree, built a television set of a company called L'Oreal, which was very small and became a big company, built it from scratch. And that was the end of my television and radio work because they were doing military work only. And once I finished that television set, you know, I had to make a choice, either stay there and do military work or go somewhere else. I chose to stay there on building stuff for the other one system, attack submarines and create water. Got around. back to the radio store. The old radio store on 78th Street, 79th Street, had both AC and DC in the store. And when the door opened, the customer came in, I knew why they came in. Because they came in with an AC set, and they had just moved into the neighborhood and plugged the set into the DC line. And the transformer went up in smoke, you could smell it coming. My biggest business was converting the sets from AC to AC-DC. Now think about that. AC set has all the filaments in parallel. You all had 6.3 volts, typically. The latest set's 12 volts. In an AC-DC set, all the filaments are series at 12 volt, 0.15 amp filaments, whereas they were 0.3 amps on the regular radios. So I had to rewire the thing, put all the filaments in series, and add a dropping resistor, which was built into the line core to make up the difference between 110 volts and 4 tubes, typically, or five tubes at 12 volts apiece. So that's dropping about 40 volts at 0.15 amps. That's 5 watts. So obviously that cord got warm. 5 watts was come out of that cord. In addition to that, I had to change the output because it was really lousy. Change all the tubes to 12 volt tubes. There's a lousy match between the output tube and the loudspeaker. We had to change the transformer. And I could do, after a while, I could do all that in about an hour and a half. And I think I was able to charge $6 or $7 for that, which in today's money would be about $20 or so. But people wouldn't pay for labor. Labor was off the table. Besides, the Reader's Digest was really busy writing articles like, watch out for the garage serviceman because he'll chip you. Watch out for the radio serviceman, he'll chip you. So people would come in, and the typical problem with capacitor, which we call a condenser, bad. People didn't know about condensers, so we shined up a tube, and we sold them a tube, and they'd pay $1 for the tube. Labor, that was off the table. That's what we did for labor. I think my average take home in those days was about $20 a week, which is like, what, less than $100 a week now. Well, we didn't live very luxuriously. So when they came in, and then I smelled these transformers, I knew I had an hour and a half's work and I was going to make money that day. But most of the problems were dumb capacitors. Opal burns out tubes of it. If you remember, those of you looked inside the old Philco sets with the multiple capacitors all in one box, potted in some black book, you know, and you had no idea which capacitor was what, and we called the condenser was what, because the leads weren't labeled. So one of them went sour, you had to do a guessing game on what you were replacing. And the other problems were RCA sets with condensers, paper condensers, where the end was crimped, the cardboard end was crimped to hold the two end places in place. It was all done by pressure. So yeah, we got a little loose, the capacitor was open circuit. It was really crummy. So most of the problem was capacitors or some electrolytics. And I had more than one electrolytic blow up, and was lucky enough to have my face in no way the liquid ones. But I also serviced the very first FM sets. Major Armstrong started FM Palisades, opposite, coincidentally, opposite to where I lived. I lived in the shadow of the George Washington Bridge. He was on the other side, on the Jersey side, transmitting W2XMN on the 42 to 50 megahertz band. So it started, and Pomona was in stereo at the time. And his first demonstrations were things like pouring water into from one glass to another glass and show the bandwidth and the extra highs that you got with FM. I went over there once, I met him once briefly. The first FM sets had all kinds of circuitry, avoid paying access to RCA to come up with a decent discriminator, the conversion of the IF signal into audio. The ratio, before the ratio detector, what was it? I got the name of the circuit, but I got a pretty good job. So sets like the early Philco FM sets used, cheated by having the second IF can detuned, so the single would sit halfway up the resonant curve, and the FM would walk up and down that curve. Of course, the curve wasn't perfectly straight. It meant you got a fair amount of distortion, especially at high audio signal level, a cheaper way to discriminate FM signal and they convert it to audio. Eventually, of course, it changed from 40 to 50 to 88 to 108, what still is today. And then stereo came along with sub area and all that good stuff. That was all after the war. Excuse me. I survived a horror show, servicing radios, 3 radios, 2 on the east side, 2 on the west side. I start off on the west side, and the girl would come in to take care of the store. Go to the east side, and go to the west side, go to the Lexington Avenue store. And when I first started, it was I'm a novice. What did I know about tools? I grew up in a big city, Germany, Cologne. I knew nothing about tools. I first encountered with a portable. You know what portables look like now? They look like overnight carrying cases with a 9-volt battery in there, and for bias, 110-volt or 20-volt battery for B plus, BTC, and a battery for bias. 3 batteries that weigh at least 10 pounds, and 4 vacuum tubes up the top. Thank you very much. Vacuum tubes up the top. And they were held to the chassis, the chassis was held to the board with 4 PK screws that went through the board into the chassis. Well, I'd never seen hex-head PK screws in my life. I didn't know anything about a spin tie. So when I got that first portable radio, I looked in there and I tried to loosen those goddamn screws with, along those pliers. Finally, I discovered, the guy who was servicing those stores before I came in, had left tools, and there was a spin tie that dawned on me. Hey, that's what those holes are for on the bottom of the case. You reach through there and loosen up those self-tapping screws and take the chassis off. That was a big revelation. I had a lot to learn in the beginning. You learn about making mistakes. And I could have cheated a lot because people would come in with their AC/DC sets, and I could plug them in on the DC line. There are 2 DC lines behind the counter, a DC and AC line. And I could plug them in. When I heard the first indication of a little noise, I could reverse the plug, and the thing would go silent. It sold them a service job. I know it was an honest job, and I didn't bless the stuff. And I would go to people's homes, and they look over me while I'm trying to fix the radio at their home. And some guy would go over and say, "What's a nice switchboard board doing a racket like this?" Because the Reader's Digest is surprised that all radio servicemen were racketeers. It's a different world altogether. I survived it. And the beginnings of Vernia was created there, and I got into the Army. The first place was the combat engineers, but all the other 6 platoons, Texans and Alabamas, and built daily bridges and barracks. I learned how to hold a hammer, which I never knew before, right? Stuff like that. And I improved my Vernia, lifting tail end of daily bridges, which are the bridges you throw up to get troops across the river or a lake. But I never did any electronics work in the Army. One of the things I encountered in my basic training was a device they had for listening to supposed enemies through a wall with a microphone you put up against the wall. It was an amplifier. It was built in 1920 stuff, very big tube. So over a weekend during a 3-day class we had, I think after 4 weeks of basic training, I built a little box with 3 tubes that you can use on a radios in those days. I made a model little device this small with a couple of small batteries. I took it to Fort Monmouth. I'm a private coming in. I talked to some officer. The whole thing was ridiculous. You don't walk in with something else. But in the first place, I was very proud of the crap that they gave us. We went through World War II and World War I stuff. You know, you have pictures of me in England with leggings on. But England was a morass of wet, damp dirt during the winter before 44 when D-Day came. And I mean, all you need is a pair of leggings to soak up with water and mud, and you're a candidate for pneumonia, which I got probably. So I tried to sell this thing. That didn't go anywhere. So I went back home. But I got my chance to build radios when I was in France. During the war, I wound up in a place near Normandy. The place was an estate that had been owned by the Vanderbilts, Gloria Vanderbilt, before the war. I have a picture of the rebuilding itself, which was done by Churchill. He used to invite himself when he came to his house in the summertime to spend time there painting the buildings and the grounds. It was a really beautiful place. It had been the headquarters of the Luftwaffe. We moved in there, and I wound up in a room in the castle. Most of the troops were down in barracks. My first electronics experience was there when the power went off. When the power went off, the guns didn't work, the sinks didn't work, and the guys had to take to the woods. Right? So I decided, nobody's doing anything. So I decided to see if I could fix it. I had been in Paris in a signal depot a week before where I picked up a multimeter and tube tester and a bunch of German mine detectors, which I eventually converted to radios. And so I had stuff. And I went into this little building, a little brick building about 12 feet by 12 feet, with a generator control panel made out of hard rubber, with relays on it. They were time delay relays, where the relays pulled a rack. The rack drove a pinion, and the pinion was a propeller. You could change the pitch of the propeller, and change the delay of how long it would take for the relay to suck in and make contacts. Well, first I drew a diagram of this thing, and I started checking with an ohmmeter. And sure enough, the computer there was supposed to be short circuit, wide open. It's a piece of wire with varnished Cambridge insulation on it. You couldn't see the break. Found it, put it back in business. Then I decided I'm going to take those German mine detectors. They had three vacuum tubes in it, batteries, of course, on the bottom, and I converted them to a regenerative front end, an audio preamp, and a power amplifier. They already had a speaker, and I made radios for the guys. I'd made a radio before when we first came to England, long before D-Day. A bunch of guys and I went to a radio store in southern England. We picked up a chassis that had a power transformer on it and some tubes. And I stripped all the stuff out of it, except for the power supply and the tubes. And I made a regenerative front end. The coil was I think probably a toilet bowl, wire on it. And I did all the soldering sitting on the dirt floor of the soldering iron in a coal fire. Right? And all the guys standing around saying, "It'll never work, it'll never work." Right? Well, it worked. One of the guys was a carpenter. He built a shelf in this little place where we had our bunks. Put the radio up there. He built a box with a loudspeaker, and we could pull the plug. And there was only one thing to listen to. We were interested. The Armed Forces Network. And we listened to Glenn Miller at night, in our bunks before the lights out. And then later on, when I came to France, I was the owner of the tower that was part of a mill building. The wheel itself was destroyed during the war. The tower was sitting there doing nothing. with a spiral case going up about 4 stories. And I had the engineers build me a workbench, and I picked up all this hardware and tariffs, including multimeter and food checker components, those mine detectors, and I converted all those mine detectors to radios up there for the troops. And that was a lot of fun. I think back to those days, things were so simple. As a radio, after the war, I was lucky to go to school on the GI Bill of Rights. I had been to school since age 14. 10 years of self-teaching myself. And I passed the entrance exam, no problem. 3.5 years later, I'm a TV engineer, built a TV set from scratch at Rhode Island. Things were so simple. An engineer, a radio engineer, could put his arms around the whole business. I built medical equipment, I built communications equipment, I built ham gear, I built commercial radio transmitters and receivers. You just did it, right? If you didn't know how to do it, you read a book or two and you did it. Nowadays, I still do toys and game design. I just showed Clark, my friend Clark Johnson, an old friend of about 50 years now, or 40 years anyway, now the electronic type. I showed him, what did I show you, Clark? Anyhow, make a long story short, let me switch gears here. I go to the Army, and I'm an combat engineer, and I really miss my radio work. So what do? I'll write a book or a story. What is the story about? On how to convert sets from AC to DC, from AC to AC-DC. Now, who in the world, except maybe 6 guys in New York, had any need for this book? No, I still have a handwritten text in my collection. Most of my stuff is the Smithsonian now. So, it was really pathetic what we had in the Army until we learned the hard way from the Germans. For example, when I got to England, we started collecting webs. We taught the troops to use the German weapons. And the German 88s all had muzzle brakes up front, which are these big bulky things like a couple of holes, a couple of planes, which take the gases and try to use the gases to propel the barrel forward to counteract the recoil, to minimize recoil. Every German gun had these that kind of recoil reduction devices. We didn't even know of them. I had a German 88 that came from the Spanish Civil War that was pre-recoil device. And we taught British troops and how to strip those guns and use those guns. Also got to fire 105s in Britain over a valley. In southern England, a part of southern England, had been an army camp for 75, 80 years. We were in there, hundreds of thousands of GIs. And the small group of MIs of which I was a part of. We taught these guys 18 hours a day, things like recognizing foreign uniforms and teaching them how to use German weapons. I recognized the aircraft. I worked 18 hours a day and taught about 150,000 troops before D-Day. I lectured to the general staff of 3 armies. I'm a private. We ran a little group. We just created this group from nowhere. We were so useful that they tolerated all this and that. Let us do our thing, but we had no support from anyone. Our great leader was a PFC who had been an officer's candidate in the Austrian army. And he was about 6 years older than most of us, but he was a real good salesman. So we put on a skit that involved secrecy and security, and some officers liked it, brought in a camp commandant. We sold the idea of teaching the troops. So, and who did all the syllabuses? And I discovered all that stuff about 5 years ago in a box that was downstairs in my basement. And there it was on mimeograph sheets, an onion skin ready to fall apart, and that's all of the Smithsonian right now. We're digressing from radio. So I didn't really do any radio work after World War II, unless you consider a television set of radio, which it is, sort of. And I built, what else did I build? Well, once we started the business, and I left L'Oreal, became a chief engineer of L'Oreal. And before we had work, he put me to work building this ham transmitter I talked about earlier. Of course, he was a ham, so I learned how to hand transmitters work. And I came up with a low-level modulation system that allowed the transmitter to pump out only about a watt normally, which is plenty to be picked up, but not good enough for voice modulation. So when you're talking to a mic that raised the pretty big voltage on the minor or bingo, I'll keep 10 watts. I got a patent on that. And that was my first introduction to the ham gear. And I built a whole lot of stuff, like a tunable loop that you could stick near your final and put across the access to the horizontal, the vertical place on your scope, so you could see what modulation envelope of the transmitter, which was very handy. Also did a lot of audio devices. The early transistor days. Talking about early transistor days, it's just after the war. I'm in New York City downtown, within about 2 or 3 miles of the Empire State Building. There's a big antenna pumping out 50 kilowatts. And I'm building a circuitry out of early point contact transistors. I don't even know what it was for, but it started working before I applied the batteries. What's going on here? It turned out the wiring picked up the transmission, and it self-rectified someplace in some of the point contact transistors, and that was, B plus, VCC, or whatever you call it, and the damn thing worked. That was a real problem when you try scoping something downtown New York. What you got was FM and television stations. The scope was full of that stuff. Many walls floating around. That's really difficult. Unless you were in the screen room, it's really hard to work on stuff because there's always interference. The television set was a really neat thing. We built it around the Philips system with a reflective optics, with a 1-inch tube looking backwards into the optics, and then a correcting lens out front. That made about the equivalent of a 19-inch black and white television set. And everything else except for the tuner we built from scratch. That wasn't easy. Trying to keep vacuum tube amplifiers at high gain from oscillating, it's always been a problem. Certainly, it's a huge problem with vacuum tubes. Now, transistors are much easier. Lay down a ground plane, and you've got decent ground, problems over, which reminds me, one of the things that he had me build, my boss had me build, was a 100-watt linear amplifier for hands. And I built this thing, well, this was a 300-watt one. But I built this thing, aluminum chassis, a panel in the middle with a tube sticking through it to isolate the output from the input. And the minute I turned on, the damn thing oscillated. And I couldn't cool it down. No. Finally, I took it apart. I sent all the bits and pieces, aluminum pieces, to be copper plated, put it back together, work like a charm. It's aluminum, lousy ground, lousy RF ground. Let that be a lesson. You want copper or not aluminum, real bad ground. For RF anyhow. You learn, live and learn. I built quite a large number of linears. After that, we sold a bunch of them too. What other experiences can I tell you about? All the horror shows, I think we've been through this, the capacitors, which were the main problem in radios before the war. But you could sort of guess what was, after a while, every radio was like every other radio. Yes, there was the same lineup of tubes, same thing. You could service them blindfolded, you know, it's so easy. So, you talk about right after the war, I get into electromedical, and among other things, I built apparatus for cutting, cutting. What is it? It's a 100-watt RF generator. What's in the box? The box is big. A big fat transmitting tube. Is there a rectifier in it? No. Big transformer, about 2,000 volts of AC. It's feeding this oscillator, which obviously puts out half cycle signals, and it goes out to a potentiometer and an ordinary piece of shielded wire, and at the end is the cutting tool. To test that thing, I has to set up a ring of chairs, put airwick on them, and fans, because when I operated on a piece of meat I got from a butcher with this thing, it smelled like hell. I tried the airwick to save me from puking, you know. But here we have doing electromedical stuff, doing muscle toning equipment, which is low voltage, low frequency wave generation. How do you generate a very low frequency wave? Well, you use a motor with a gear train inside. Who made those things? AC motors, they were everywhere in every appliance. And that turns, the motor turns the switch off and on. And the switch turns the filaments of the rectified off and on. And the power goes up, and the power goes down, right? That's how you guys sinusoidal low frequency AC. There's also primitive. I built a depilation machine for hair removal, which was an RF oscillator. I controlled it with a gas filled tube that was supposed to be turned off with what was that? I forgot how it was supposed to be turned off, but I found out I could turn the damn thing off with a DC voltage, and that in turn turned the depilation machine off and on. I sold quite a few of those. Today the FDA would go after us and put us in jail. This stuff, and noise generators, yeah. What else did we build there? And I did all the hardware too, you know. I drilled out the chassis, mounted the sockets, mounted the power transformers, mounted the motors and all that jazz. Made everything by hand, except for the panel which we sent out for engraving, plastic panel for engraving. Things were so simple. And now I'm working at L'Oreal. I'm going to leave radio for a minute, and I'm building this television set. And what do you use to align a television set? You go to Heathkit and you buy a Heathkit generator, which allows you to put vertical, horizontal bars up, so you can tweak the linearity adjustments and all, the width, and the height, and all this good stuff. And I look at that and I say, this is pretty neat, you know. You're interacting with that television set. You're turning knobs over here and something's happening on that screen. I said, hey, I said to the boss, why don't we build something like that into a TV set? And the answer, of course, I don't know, you're already behind schedule, forget it. You know? And the idea came back in '66, and I scribbled it on a piece of paper while I was in New York. The next day, September 1st, '66, I wrote a 5-page paper that lays the whole thing out. You know, how you interact with television, how you get inside, what games you can play, you know, with relatively simple circuitry. It's all there. That's how it all started. I ran a division of about 300 to 500 engineers in Nashville at Sanders Associates, and put a couple of techs to work part-time. And by the end of '67, a year later, we had put in maybe 100 man-hours at most, maybe less than that. We were playing ping pong. And we brought in guys like the head of cable company from New York, biggest cable company at the time. We were in Con, he was Mr. Cable. The concept was we would have the cable provide colorful backgrounds, and we key our simple symbology on top of it, like the background of Wimbledon tennis court, and I play on top of that. And actually, we actually went to contract, but the cable business was so poor, their cash flow was negative, and it all disappeared. But by this time, we're shooting at the screen with light guns. We have joysticks. I have the system of putting audio into the video game and having come out of the television set by having a 4.5 megahertz FM oscillator in the game box, which gets summed up with a carrier, channel 3 or channel 4 carrier, and it comes out a loudspeaker on your television set for instructing people how to play a game. I just showed it to Clark this morning. I have replicas of the old stuff in the house. I did that because I had to demonstrate the early games to the president. I mean, as president, vice president, I'm working for him. And I knew I was going to have to do this when the whole board of directors was in. I knew I was going to face about 10 guys. I didn't want to blow it. So I recorded instructions, verbal instructions for each of the 8 games that were in this box, switch control, on audio tape. I built a 4.5 megacycle oscillator, summed it with a channel 4 carrier, and came out and speak of the television set. So before I play the game, I push the button on the tape recorder, and out comes sound from the speaker. In my demo, I have a voice chip. It does the same thing. I turn it on, push a button, and it speaks. And it speaks. And everybody says, most guys weren't very supportive. 2 or 3 of the members of the board of directors were very supportive, and they helped me for years. But for the next year and a half or so, I was trying to find somebody to license all this stuff to. I was mostly asked, are you still screwing around with this stuff? Which was not the question they asked me, or 10 years later, money was coming in so fast, I was making more money in the biggest division in the company. And then, there's a flag up on the South Nashville plant with my name on it, and Bill Edwards, who was the director of Baptist Review at Tucson, running the show. And I get to quarterly meetings and look at the big screen, and returns on video game licensing were always bigger, and the money coming in from the biggest division sectors. So obviously we could do what we wanted to, and we did. I used to ride home at night, having spent the day on something interesting that I wanted to do with a bunch of guys. I usually get $150,000 to $200,000 a year to do what I wanted to do. I get about home and I'm jumping up and down. I can't believe this. Getting paid, having fun, getting paid, and doing a company a lot of good. For example, we built a video game that was very complex. We wanted to play come on, tell me. Game where you push the buttons, flipper.
Pinball.
Yeah, pinball game, thank you, pinball game. So what we do, we point a camera at a real pinball field, and we tape this. Now we have to load data into the tape. It says this bumper is at this X and Y location, that bumper's over here, that bumper's over here, and bury that as code on the videotape. That took a lot of doing. It took about a year and a half to do all this. So now we're demonstrating this pinball game, and in come 3 special forces guys who stand there and watch it. And this works like a charm. When we get done, what do they ask? Can you shoot at Russian tanks? All of a sudden, I took a microsecond to answer. Oh, sure we can. All of a sudden, I'm in the military weapons simulation business. Made it into a big business for Sanders, for nothing. So you never know how things go. Keep your eyes and ears open. You're not afraid to jump into something new. And I always had really good guys working for me who know a lot more than I did, especially in software areas and other areas. There's no point in working with guys whom you have to teach. And always careful to give guys credit for what they did. Never had the slightest problem with people. So, had a really good run at Sanders. I got invited in December to speak to a bunch of engineers. And I'll be there again in May for another talk. A bunch of engineers. It's just fun. It's like being a bunch of guys interested in much the same stuff. And just talk about old times. My times were so primitive. Think about this. When I first worked at L'Oreal, they gave me, after I finished the television set, I had to build a part of this airborne system that took information from an aircraft so that their radar could track a submarine down below, which meant tilting the antenna to follow the sound. So we got information from a compass heading gadget up on the plane. Airspeed came down, and you have no idea how this information came down. It's all electromechanical. The sinkholes up on top, and they rotated, and 3 wires would come down. Another sinkhole at the bottom rotates, and they put a pot on the end of it. Now you get a varying DC voltage and function what's going on up there. What do we do today? We put a sensor up there. That's about so small. It's got a microprocessor in it. It radiates, and they pick it up down below. And your microprocessor handles it along with 16 other things. Could care less, you know. Of course, I just showed my pal this morning the processes I use today. I have a product at Toys R Us. It's a trike. And the processor in there is made in Taiwan. It's got about 60 pins. It has tons of memory. It has 60 seconds worth of audio storage on it. You play it backwards, forwards, slow, fast, for effects. And then in quantities of 100,000. The chip, which it's automatically laid down on a PC board, the chip's 27 cents. There are several tens of millions of transistors working for us at 27 cents. It's just a completely different world. Think about it. I built a intercom when I came back from the war. I built it after coming back from college in Chicago. I built an intercom that was switchless. I would switch to whichever side spoke into the speaker. That acted like a microphone first. So if you talked long enough and didn't take a breath, you could keep hold of this thing forever. What was in there? 6 tubes on one side for one channel, dual trios like 6 SN7s or 6 SL7. 6 more tubes on this side, a couple of tubes in the middle, a rectifier, and a gas voltage regulator, plus power transformer. They weighed a ton. Figure it out. There's 6 dual trios here, and you got 12 tubes, 13. Each one ran at 0.15 amperes, so that's 20 watts right there. And heat going up in smoke before we even start. I need a power supply of at least 90 volts. It starts out at 150 and gets dropped. And the voltage regulator is another 10 watts there. Today, we do this with 50 milliwatts on a single chip. On the corner of something that's doing 6 other things in the world. I show this, the problem from an electronics point of view. The problem with that machine was how do you switch noiselessly from one direction to the other direction. So I came up with this balanced modulator scheme. Only I didn't know it was a balanced modulator. I found out, I invented all this stuff while I was sitting on the subway doing the work. In those days, you still got a seat in the subway. And about 3 years later, I opened up a RCA textbook. And there's the balanced modulator. No, it was a telephone company manual. There's this balanced modulator. So I reinvented a balanced modulator. I needed a switch that switched 2 ways. It didn't make a noise in switching. So it wasn't complicated. If you use a noodle, you can always stay 1 step ahead. If you don't use a noodle, you'll always be a step behind. I just showed Clark this morning something I'm working on. It's remote control. The remote control sends out the same code as a Sony remote control. The chip I have, the microprocessor I have, is a brand new one, and I'm just getting used to it. And I couldn't get it to work. Turned out that you can output the IR carrier, which is 38 kilohertz on all the remote controls, and the code for 0, 1, 2, 3, 4, 5, 6, 7, with just one line command. And any pin on that processor will put that thing out. I mean, this is bloody miracle. You know, I used to have to output the 38 kilohertz in one place, and then the data in some other place, and then make the data modulate the 38 kilohertz. It's a one-line command, you push the button, bingo. This is unbelievable. But it took me 3 days to figure it out. Why? Because I didn't read inspection. On the very first line it says, you know, this thing comes out as an IR signal modulated with the FM code. No. And in my wildest dreams, I didn't think I would do that, because it was always separate from the older version of the processor. So I ignored that line, you know, and I spent 2 days trying to get the thing to work. It won't work. Because I didn't read. At this point, maybe how about some questions? The audience.
This is more of a personal question. How did you get out of Germany?
I'm damn lucky.
Yeah.
We had lots of family in New York on my mother's side. So the third generation there. And they provided affidavits. And my father saw early on, he had been in World War I along with 2 other brothers. One got killed. He got wounded twice in the German army. Didn't count for nothing. He's got all these medals, didn't count for anything. And we lived in Cologne. And he knew it was coming. And he worked very hard. The Germans made it very difficult. We got out in August of '38. Crystal night was in November, when it really started getting dangerous. And I have, on my father's side, there were 4 sisters and 2 remaining brothers besides my father. And that entire family all got wiped out. Husbands, wives, and some of the kids made it. And I know the exact date on which they died and the camp in which they died, because the Germans were real good at keeping track, keeping records. So, yeah.
Thank you.
On the tennis, was that take long to develop, or, you know, over a course of a period of time?
You want to hear about this stuff?
Yes, please.
Okay. About 1975 or so, I get restless and decide I'm going to do toys and games as NIDO. I'm still at Sanders. I'm an engineering fellow. And I build stuff, but I really had no contact in the industry. I didn't know what the hell I was doing. And one day I'm going down into the Canal Street lobby to a vendor of integrated circuits, and he said he had been in the toy and game business 7 years before. He says, "Have you ever heard of Marvin Glass, toy and game designers in Chicago? Why don't you call them? Maybe they want electronics capability." Make a long story short, for the next 10 years, I'm the outside capability for Marvin Glass. That's what we did. Simon has disappeared. Simon and many other games with early single chip microprocessor like Simon has a TMS 1000 in it. It's a 4-bit microprocessor with 1 key of memory, which we used to program with a big rack full of teletype, paper tape, keyboard, communicating at, there it is, communicating at maybe at 200 baud with a telephone line to some computer that TI ran in Pennsylvania somewhere, where the software was with this chip. And every month my telephone bill would come in looking like the national debt, you know. And it took forever. And of course, then we'd start demonstrating to people. And very early in the game, Milton Bradley took a license. And then they came in with, well, we want to, this ad, we want to add this, we want to add this. And my software guy was a mathematician, very good one, had to repackage the memory, which was, so primitive anyhow. That was a job. But think about what makes a product popular. One of the things that sold Simon was the sounds it makes. Well, what sounds do you pick? When you have 4 sounds to make, how do you pick them? You have to have sounds that sound reasonably consonant, with each other, no matter what sequence, which sequence, and which sequence you play them. So what did I do? I went through my kids' contents encyclopedia until I got to a 2-line stretch of music, and I can't do it now. I could read musical scores and say, hey, that's it. The bugle plays this entire repertoire, G, C, E, and G. G, C, E, and G it is, right? And all the copycats who came along didn't know that, and they put other stuff in there. And a lot of people play this thing mostly by ear. And it's just much easier to remember these related tones. Yeah, I made a copy of that page in the encyclopedia. And that's on display with one of the early machines, the Museum of Play in Rochester, New York, which is a fantastic place. It just has one big problem. It's in Rochester. And if you want bad weather, they have a whole block, extremely well endowed, by a woman who first endowed Kodak. And she has a huge museum-type storage facility downstairs that will become another museum someday. They're wonderful people up there and do a great job, except that it's a hell of a trek up there. It takes a good 6-7 hours to get there. Usually, the Mass Turnpike takes we stop off in Massachusetts at the Norman Rockwell Museum, because my in-laws had a Rockwell picture which we donated there, so we go by there. The ERP's there when they take it around. Which is kind of nice, breaks up the long trip. It's right off the Mass Turnpike once you leave New York. What the hell is the subject? I forgot. We had another advantage. When Simon first came out, the movie, what's the name of the movie? Come on.
Close Encounters?
Yeah, thank you. Yeah, it was contemporary, that movie. And it had a rotating disc, and it made noises similar to Simon, and people associated with it, and that was a plus. Simon actually got introduced to the public downtown at Club 54, and they had a whole bunch of celebrities there. I'd never heard of the place, but the night before we were at the big hotel downtown, and the limo picked us up, us being 6 or 7 guys from Hourglass and me. And we walked into this club, out of the limo, the crowd's parted, and we walked in like royalties. And here's a scene of these people doing something that's supposed to be dancing, right? The stuff rotating on the ceiling, and raucous noise. And most of us escaped to the 3rd floor. It was an old theater, trying to get away from the din. And we were 10 of them. They finally demonstrated a big sign. And then there was all kinds of celebrity on stage playing the game. And I didn't even know these guys. About 2 years ago, I come across a magazine article that describes this whole scene in great detail. So of course I copied that out and I stuck that in the next generation of my bio. Really funny story. We last time until about 11 o'clock. I couldn't stand it anymore. And this time the streets are empty, couldn't hardly find a cab. Yeah, we were in the Waldorf Astoria before that. I was in the Waldorf Astoria another time when I was chosen as the inventor of the the year by New York State, and the mayor sent some representative with a big plaque. And I gave a speech, a bunch of lawyers talked. Going up in the newspaper the next day. I've had a lot of exposure over the years. And I was telling Clark, 3 or 4 years ago, I was still traveling. We're in Holland, in a small town. And we were in a church. There's no religion up there anymore. The pews are gone. Everything is gone. There's a platform there where the altar was, and mics up there. And there's still an organ in the back, high organ in the back, chairs set up, and lectures are going in there. Right? I go forth in there, and when we get done, I demonstrate a brown box for a video game. And the mayor comes in, the medallion and all the stuff. And I play against the mayor. Of course, I beat him. Next morning, on the local newspaper, headline is Baer beats mayor. Had a lot of fun for the years. Traveling mostly Europe, France, Germany, Austria.
Your favorite place in Europe, Ralph?
It's Holy Port. Mostly a game development conferences, video game development conferences. Got invited. And then we toured around. Of course, my middle son was my marketing type, my business manager. His family, they're all skiers. They live in Salt Lake City, avid skiers. He's a ski instructor, And so whenever we go to Germany, we go to the Alps and they ski. And I sit in a lodge someplace. Yeah. Get online or reading a book or something. I ain't going up there. I tried skiing once, and the ski went this way, and I went that way. I was in a crutch for the next 6 months. It was on the end of my skiing.
How about 2 more questions, Ralph?
Sure.
Mark?
How did the Smithsonian locate you?
You're going to have to repeat it for me because I can't hear it.
Go ahead, Mark. How did the Smithsonian locate you, and what do you have in the Smithsonian?
Okay. My son invited Smithsonian people to come in about 1904. And 4 people came up from a couple from the Lemelson Center, the other 2 or 3 from the museum, American History Museum. And they looked around. My place looked like a museum with all this stuff all over the place. And their eyes went like this. And the guy from the Lemelson said, I got to have this shot. And it's topical now. My son was at dinner with us, Clark and I, and he told me that he'd been in touch with the guys, become our friends. And they want to set up my replica of my lab. In fact, they want my lab. Send somebody in to take pictures and rebuild the thing, and they come into, and their center is right on the other main entrance. They come in, they're in the corner there will be my lab. And I'm happy to do it because it's the only way I can get rid of all my Old Testament. Nobody wants it. I have a whole bunch of components, which I talked to Bruce about. Nobody wants this stuff. I was able to give away a bunch of stuff for useful for hands, coils, high voltage capacitors and stuff like that. And somebody walked off with that. And every once in a while I look for it and I go, actually, I gave that away. But I have a ton of stuff I can't give away. It takes.
We have a free table right outside. But if nobody takes it, you have to take it back.
You won't believe how hard it is to give stuff away.
Understood.
So,
One more question,
these guys
anybody?
came in from the Smithsonian,
One more.
and we got acquainted. And little by little, they decided that they'd like to have all the original hardware. I came to the position of the original hardware because I've been through all these lawsuits for the law firm in Chicago, and they had stored that stuff very carelessly on the lawyer's desk. And finally came to the realization that, hey, we really should salvage this stuff. They had already lost a couple of them, but we recovered them. And I was able to construct a legal way for that stuff to leave the law firm, which they should have turned over to us after the end of the lawsuits anyhow, and didn't do, and have it progressed to me for the purpose of donating it to a major public institution. So there's a legal track of how all this happened. That's fine. So we ship, they come, they look at all the original equipment, eventually goes to them, and it sits there. It hasn't been displayed very often, because you go downstairs into the vault, it's just an incredible collection of stuff. They can display maybe 10% of what they have, maybe. Go down there, here's the sewing machine, 1857, here's Morse's first key, here's the can opener from 1879, it's just unbelievable. All laying around on shelves and quite open, it's incredible. I've been down there many times, we made a movie down there once. We've got all this stuff, it's at the Levelson Center. The Levelson Center is a center for kids to be taught electronics and electronics history and all this good stuff. I've been there a number of times once to speak to a whole bunch of kids and their parents and play an original video, brown box video game for the kids and for the parents, and have the kids come over and play, for which they brought the original box out. And once we were down in the vault, they were making a movie, and they brought the old box out, and that brought me in, and before we made the movie, they had the box laid out on the table. Behind it is this great big box. You open the box, there's an Atari bomb game in there. And I look at my old brown box, and there was a monitor, which turned it on, didn't work. I brought my own brown box, plugged it in, it didn't work either, so it looked like the batteries were dead, battery operated. So somebody ran off